Hi, my name is Lu Wei Jun, and this is my group members, and today we will present video assignment for Engineering Mathematics 1. So this is the question 1, and this is the equation. We need to put this equation into the matrix form, and this is the final matrix, and which is the input data. So question 1, we need to find the highest eigenvalue and the eigenvector. And B, we need to find the lowest eigenvalue. So this is the input data, this is the initial eigenvector, and this is the error. So we use power method and prove it by using Excel and MATLAB. So I moved it to the coding. So this is the coding, which is the input data. This is iteration 1. This is the tolerance error. This is the initial error. And this part is the initial eigenvector, 111. So there will be a menu for you to choose highest and lowest. So the highest eigenvalue will be equal to A. If we choose lowest eigenvalue, so we need to inverse first. So here is the main part for the coding. So xo equal to x, which is to preserve previous eigenvector. This is to compute new matrix. This is to compute largest eigenvalue. This is compute new eigenvector. This is to store eigenvector values. This is to compute errors. This is to update eigenvalue. This is for display purposes. And after that, we need to update the iteration counter. So I copy it to the MATLAB first. So here is the MATLAB, so we just paste it. So here will be the highest and the lowest. So first, question 1a, we need to find the highest eigenvalue and eigenvector first. So we click it. So we will get this answer, which is eigenvalue, highest eigenvalue is this, and the eigenvector will be this. So for question 1b, we need to find the lowest, right? So we do it again and pick the lowest. So here is the lowest eigenvalue. So this is my part for this question. Thank you.
Hi, my name is Tan Hong Yi. Next, I'm going to solve the eigenvalue and eigenvector question by using Excel. So from the question, we have these two equations, and after comparing these two equations, we have this value. So we sub all the value inside the matrix A, we will have this matrix. So we set the initial value to 111 and the error tolerance to 0.0005. So A, we want to find the highest eigenvalue and its eigenvector. So now we insert the matrix here and we set the initial value to 111 and error tolerance to 0.0005. So by multiplying A times X, we have these three values. So we can use MMULT to multiply these two matrices. So this will be the maximum value of these three, which is 22. And this, we take 20 divided by 22, 17 divided by 22, and 22 divided by 22. And now we have these three values. So next, this matrix is still same, but now we change the matrix X with the new matrix, which is this 3. Again, we multiply these two matrices and we have these three value. So we taking the highest value and factorize them, and we will have these three value. So AV1 minus AV0, then we put it here. So this value we need to use the modulus, which is ABS. And now we're taking the highest value as the error. So now since the error is still larger than error tolerance, so we continue the iteration until here, the first stop here. The error is now less than the error tolerance. So we stop the iteration, and here this will be the eigenvalue and eigenvector, which is this eigenvalue and eigenvector. So B, we want to find the lowest eigenvalue. We insert the matrix here and we find the inverse of matrix by using inverse. So this will be the inverse of matrix. It's the same initial value and same error tolerance. So we multiply both matrix by using MMULT. We will have this 3 value. So we are now taking the highest value and factorize the value. The matrix is still same and we set the value with this 3 new value. Factorized with the highest value and now we have this 3. AV1 minus AV0 and we will have this 3 value. Again we take the highest value as the error. So now the error is higher than error tolerance. We will do again the iteration until here. Stop. The error now is less than error tolerance and we stop the iteration. So this eigenvalue is 0.2942. We divide 1 over this 3.3985. We have this value. And the vector is still same. After completing this question, we can observe that by using both methods, we will have same value. So that's all from me. Thank you.
Hi, my name is Sojotik. Next, I will explain about question 1.2. Without further calculation, write down the highest eigenvalue and the lowest eigenvalue and eigenvectors of the following matrix B and C. First, I perform with Microsoft Excel. Find the difference between A and B and A and C, and I will see that the difference between A and B is one identity matrix, and difference between A and C is two identity matrix. By rearrange the equation, I will see that the matrix B is equal to matrix A plus identity matrix. However, matrix C is A minus 2 identity matrix. By use this equation and I replace 1 into the identity matrix, and I will get the highest eigenvalue and the lowest eigenvalue for the matrix B and C. For the matrix B, I use eigenvalue of A plus 1. For matrix C, I use eigenvalue of A minus 2, then I inverse it. All of the eigenvector remain the same as the eigenvector of matrix A. Next, I will present about MATLAB. First, I insert all the matrix A, B, and C. Then I apply the difference between A and B and difference between A and C. And I rearrange the equation. I will get that A plus identity matrix for B, A minus 2 identity matrix for C. And find the highest eigenvalue of B and lowest eigenvalue of B by plus 1 with the eigenvalue of A. This is highest and this is lowest. For highest eigenvalue for C and lowest eigenvalue of C is use the eigenvalue of A minus 2, then inverse it. And lastly, compare the answer for MATLAB and Excel. I will get the same answer. Okay, that's all from me.
Hi, I'm Paul. So let's continue our question 2. So we're given a circuit here, the series RLC, a table, data of charge collected at different time t. So let's at the question A. Okay, if I return to table 1, we need to determine the IT and ET for all time t, which is 0 to 0.7 at its highest accuracy. And we need to plot the IT versus time graph for question A. So IT is equal to dq over dt. In order to do this differentiation, we need to do numerical differentiation. Numerical differentiation, we have two methods with Taylor expansion and higher accuracy. Okay, higher accuracy. So I'm using higher accuracy finite difference methods. So this is origin data over here. So in order to get the dq over dt, we are using this picture over here. Okay, you can use this formula. So in order to get the highest accuracy, you can do FDA for first 2 points, because in order to do CDA, we require 5 points. Okay, like 0.2, for example, 0.2, we need to have 0 until 0.4. So cannot perform for first 2 points, cannot perform CDA. But well, for 0.2 until 0.5, we can do CDA. Then the last 2 points we do BDA. Okay, so by keying the formula over here, okay, you can see the first 2 blocks is the first 2 points of 0. Okay, then the second point, and the last point, and then the step is 0.1. Okay, for CD also the same, by using this, following the formula over here, the picture over here. And then you get dq over dt. So in order to find et, right? So the question A is to find et. So et is given this equation. We already find the dq over dt. Then we need to find d square q over dt square. Okay, so we do a second derivative. Okay, in order to do second derivative, it's very simple. Also formula equation, follow the equation over here, the picture show here. Alright, so you can see this the d square t over dt square. Okay, also it's the same. The first 2 points, 0 until and 0.1 we do FDA, and 0.2 and 0.5 we do CDA, and 0.6 until 0.7 we do BDA. Okay, by keying also key in the formula same as this picture show, and we get our second derivative of qt. Okay, so we need to, in order to get et, we need to use this equation. Okay, so by also we key in the formula over here, is the same one, or is the same one, and we get our et value. So let's continue. We need to find it versus t. Okay, so here is the graph. T is over the left axis, and the x-axis is the time. Now you can see the current is decreasing over the time. So for et, you can see it's decreasing until 0.3, reaching its max. Then it will decrease along the time. Okay, so that's all. And then we get the 10 marks for this question. That's all for me. Thank you. Bye.
A very good morning and good day to everyone. My name is Yap Zishan, and today I'm going to proceed with the next part of our presentation, which is proving the answer we obtained from Excel with MATLAB. So first, I'm going to key in the data for both time and charge given in the question in an array form. And then next, we know that the current can be obtained by differentiating the charge. So here, for current 1 and current 2, we are going to use the formula for 3-point forward differentiation approximation. And yeah, current 3, 4, 5, 6, we're going to use the formula for 3-point CDA. And current 7 and 8, we are going to use the formula for 3-point BDA. So after keying in the formula and also the data, we put the current obtained in an array form as well, and here's the data for current obtained, which is exactly the same as the answer obtained from Excel. Next, I insert the command plot time and also current, and here's is the graph obtained from MATLAB, which is exactly the same as Excel. Next, we are going to calculate the differentiation second derivative for charge in order to put them into the formula for ET. So again, we are going to use the differentiation dA formulas for D2Q. D2Q1 is basically the second derivative of charge number 1. Okay, so similar like just now, D2Q1 and D2Q2, we are going to use the FDA formula. D2Q3, 4, 5, and also 6, we're going to use the formula for CDA. And lastly, D2Q7 and also 8, we are using the formula for BDA. Okay, now we in similar like just now, I insert all the D2Q values into an array, and here's the array obtained, which is again the same as the answer obtained from Excel. And next, I define the value for R, L, and also C so that we can place them inside the ET formula. As we know, ET is equals to L times by D2Q, the second derivative of Q, plus R times the first derivative of Q, plus 1 over CQ. Okay, so similar like just now, we key in the formula and also the data points for charge and also current. Okay, so here's the calculation, and finally we place all the E values into the ET array, and here's the values for ET which we obtained from MATLAB, which is again the same as the answer we obtained from Excel. Okay, next we type in the plot bracket time, also ET command, in order to plot the graph for time against ET. Okay, and here's the graph obtained for MATLAB, which is again exactly the same as the answer obtained from Excel. So this further proves that the same answer will be obtained from both MATLAB and also Excel. So that's it for my presentation. Thank you.